First of all, wanted to thank everybody for your time today. My name is Chuck Yasayan. I'm the COO here at JMH Group. We're excited to introduce you to CR Flight as part of our ongoing educational capabilities briefing to the JMH Group network. This session is expected to go for roughly an hour, with about 20 to 25 minutes for the presentation, followed by 25 to 35 minutes of Q&A. We're recording this briefing for those that are unable to attend and for you to be able to share internally with your respective teams. This presentation and recording will be sent to each of you soon after this capability briefing concludes, likely before the end of the week. We encourage you to utilize the text chat function during the briefing so that we're able to address as many questions as possible during the Q&A portion of today. Also, please mute yourself until the Q&A section begins. As background, CR Flight is headquartered in Northern California and has developed a patented propulsion system called eVector, where the initial use cases will support avionics, maritime, and covert operations through improved efficiencies in thrust, payload, and range. We have multiple members of the CR Flight team with us today, including John Amy, the CTO, and Rick Pedigo, the Senior Vice President of Business Development and Sales. They will be going over the slides with you. Following the slides, as I mentioned, we'll open up for Q&A. We'll go through the questions that are listed first, and then follow with any verbal and follow-on questions thereafter. Thank you again for your interest and participation. And John, Amy, please take it away.
Well, my name is John Amy. I'm CTO for the company and co-inventor. Basically, what we've created is a fairly simple technology that allows us to conduct high amperage, high voltage at high RPM. That kind of a joint has never really existed before, and it allows us to actually put it onto an electric motor and get counter rotation out of a single motor, while also improving the cooling by about 100 times, because now we're spinning the armature. We're going to go into more detail on that, and Rick's going to cover those areas.
Hello, everybody. My name is Rick Pedigo. I'm Senior Vice President in charge of Business Development and Sales. I'm going to talk a little bit here about the technology and what we're doing with this. Essentially, what we've come up with is a technology that allows you to take any motor that is a conventional motor. It has a stator, which is a stationary part, and a rotor, which is the rotating part, and convert it into a counter-rotating propulsion system. What we essentially do is we're able to take the stator, which is normally stationary and has the electrical current on it, and we've created technology called eVector that allows us to run that high current into the rotating part of the motor. So it allows us to spin the stator of a motor. So the advantage you get from this is you get a counter-rotating prop system, and I'll talk about the advantage of that, using a single motor. And this is the unique technology that CR Flight's come up with. It's patented. It has applications for any type of propulsion system or any type of counter-rotating prop system. So it can be used both in maritime as well as in airplanes. Can also be used in wind generation. So there's all sorts of different applications that we've actually tested this on and produced parts for. That's just an example of how the parts are working and go together. What essentially this does is this provides us up to a 40% increase in propulsion efficiency. So this is not motor efficiency. The motors themselves are already pretty high and efficient. This is your overall propulsion efficiency. So this is from your battery all the way to thrust that is generated. And we basically do this by attacking 4 different areas. Number one is just the linear thrust, and I'll talk a little bit about a counter-rotating versus a traditional prop system. We have a rotating armature, so we run cooler because we're rotating both pieces. We have no imparted torque, so we call that torque harvesting. A good example of that is if you take your drill and you push the handle on your drill, you can feel your wrist turn. That's the torque. Because we have a torqueless system, we're harvesting that energy. And then we also run at a lower propeller speed. Essentially, we're halving the propeller speed because each prop is spinning opposite each other. So we're spinning each propeller at half the speed of a normal motor. This allows you to put a larger prop on and allows you to optimize the prop and get a higher efficiency out of your prop system. So this 40% increase in efficiency, propulsion efficiency, can be directly translated into 40% more payload weight you can carry, 40% more extended range you can get from UAV. Depends on how you want to play that game. You also get better handling, more stability, more durability. We'll talk about that. And you also have a reduced signature because, again, you're running the props at a half an RPM, so you have a lower acoustic sound. So, you know, if you're familiar with counter rotation systems, there's a lot of benefits that counter rotation just by itself brings to you. In a conventional airplane, the prop, it creates what we call, you know, rotational thrust. And that rotational thrust has kind of two bad things that it does. Number one is it affects your control surfaces in your airplane. And therefore, you have to counteract that. That adds more drag to your system. You're basically losing a little bit of the benefit of having your propulsion system. The other thing it does is it adds torque. If you're an electric airplane and you're trying to take off, let's say for a short runway, a lot of the electric airplanes, the Cessnas right now, for instance, you're limited on how much throttle you can provide because you will literally tip the airplane over due to the torque of the electric motor. As we all know from Teslas and stuff, they have high torque, immediate high torque. And so what our system does is it takes advantage of those counter-rotating benefits, but it does it, you know, torqueless. It also gives you the linear flow that you get the advantage of a counter-rotating system, which means you don't have to use your control surface to counteract that rotational thrust. Generally, it's about 15% increase in efficiency just by having counter-rotating props. The downside of a conventional system is you have complex gearing or you have multiple motors in order to achieve that. And typically, that's what people do. They either use gearing, which you have losses through the gear, you have more complexity, adds more weight, or you take two motors and you put them opposite to each other, and you run counter-rotating, counter-props that way. But that requires an additional speed controller and an additional motor. We have eliminated all that and do all of this in a single motor with no gearing, no second speed controller. It's all done as just a single motor with spinning the armature or the stator and the rotor spinning opposite to each other. And so you can see here that's a traditional motor on the left with a stationary stator. And what we've done is we rotate that stator. That's, again, how we create our counter-rotating system. And the way this is done is through the eVector technology, which is actually the part sitting on top of the armature in this photo is where our eVector is located. These are some examples of coaxial systems that are typically out there right now, where you have two motors and you have twice the motor, twice the speed controllers typically. Just kind of another examples of how these configurations are currently done in systems that are out there today versus our simple single motor design. And again, here's an example, two motors versus a single motor. This is an exact replica of it. This is a T motor U8 motor, and this is what we've converted that T U8 motor directly into our eVector. This technology can be applied to any motors. We're not a motor manufacturer. We're the technology of the eVector behind it, and we work with motor OEMs, any motor OEMs, to incorporate this technology into it. And so that's kind of our path going forward, is working directly with motor manufacturers to incorporate this. So if you have existing motors you're using, we can work with that motor manufacturer and incorporate this technology into it. The next couple slides are some videos. I'm going to turn it back over to John. He's going to describe the videos of what you're seeing of some of the motors that we've made. Back to you, John.
What you're looking at here is three identical motors. We have one motor on the right that has our technology on it, and then we've got two motors on the left. We had to do that because when we tried to balance it one motor to one motor, we just burned the one motor up. So we do the two motors to do a balancing on this to show you basically what the savings is for our technology versus the standard motors. As you can see, it's a significant drop in power required.
And John, you want to describe, those are the number, the 26 point or the 25.1 versus 16. That's the actual.
That's the actual amperage being pulled by the two sides. 25.8 amps is being pulled, 26 amps being pulled by the double motors, and 16.7 by the single motors. And we did a balance, so you can't cheat it. You can't make it work better one way or the other because you're now balancing load to load. And then again, single motor versus two.
And you can see from the very beginning that the weight is significantly different, obviously, with the extra speed controllers and props. So you're saving weight as well as drawing lower power to get the same amount of thrust.
Yeah, I was going to mention, you are looking at slightly heavier load on the double motor side because there are two motors and two ASCs, etc. But that's also part of the real world.
Hey, John, this comes up later in the grams per watt.
Yeah, well, obviously, you've got 16.4 amps. This is actually a demonstration of an underwater motor that we put together, and we did a duplication with the factory motors in the back. This is the one on the front. We're just spinning one motor so you can see what the standard motor works with. Notice the cavitation coming off of that motor as well, which is pretty standard for a water. You'll notice you're pulling around 26 amps, and you'll see the thrust meter on the side. We're going to then switch it over to where we engage our second prop and watch the cavitation of the water as well. Your cavitation drops off absolutely dramatically. Your thrust is exactly the same, and now you're down at 16 amps versus the 26 amps that you were running before. So it shows you that whether you're in air or water or any other medium like that, it pretty well works that way. And you're getting about the same type of a savings. This is also a graph where we took a T motor, a U13, which I consider to be one of the best of the T motors, and ran its performance. You'll notice that there's a blue curve. That is the stock U13 T motor. We take it up to its maximum performance, where you see the 6 there, that's 6 grams per watt. That's the max it can hit. If you go past that, it goes directly into thermal runaway and you burn your motor up. The upper one is exactly the same motor, but with our technology added to it. And you can see that all the way across the entire performance range of the U13, we're running about 30 to 40% more efficient. But the other part is we can double the capability of the actual thrust capability of that motor. That motor can produce around 30 to 32 psi or 32 pounds of thrust on a constant basis. We can produce 50 to 53 pounds of thrust on a constant basis. The other real advantage to this is that we can actually, I've run that motor up over 100 pounds of thrust for about 30 to 40 seconds, and then took it back down to see what it would do. It was starting to heat, but it was not by any means approaching any kind of a failure mode, which tells me that that motor can, because it's sucking so much air through it, you can pull that power probably reliably for like a minute, minute and a half if you had to get something on the ground. And you had to crank up that motor in order to get it. We rated it 50 pounds of thrust. That's why it's called the V50. We rate our motors at what they can run all day long at, not what they can run for 2 seconds. This is one where we're showing the heat cooling capabilities of the motor. These are 2 pictures, a base motor running at the same power levels, and you'll see the motor went up to 108.5 degrees C. Our motor is running at 7.5 degrees C at the same power level, but with our technology on it. Because you're spinning the armature, you're getting about 100 times the cooling capability as you do off of a standard motor just flying through the air. So the things that we affect is the thrust efficiency, obviously the cooling mechanism, torque neutralization, which is a very big thing as far as what Rick was talking about. You got to take off in a hurry. You just power it up and go off the runway very quickly. Heavier payload per watt, longer flight time. One of the things that's important here too, because we're not pulling the amperage out of the batteries and pushing the battery amperage capabilities, we don't overheat the batteries either. It allows the batteries to run cooler. Longer flight time, lower audible signature. Again, what Rick had mentioned, you're spinning a slower prop, so you don't have the whine, the loud whine that you normally have, and superior stability because you're not dealing with torque. These are the areas that we've already worked with. Obviously, aerospace is one of them, whether you're dealing with a hybrid, a copter, or full-size aircraft. The other one is marine propulsion for your commercial shipping and naval operations. The one thing we found is that this is highly scalable. We don't really care how big of a motor you want to put this on. It scales up just fine. And what we've actually found is as we go up in size, our performances actually get better. Renewable energy is your hydroelectric generation and wind generation. Obviously, with hydroelectric, it allows you to put a second propeller on the same generator and basically double your power output out of one generator because you're spinning it now twice as fast. With the wind generator, the main thing that kills wind generation is transmissions going out all the time. Well, we allow you to do two things. One, you can either cut your transmission in half because you're not having to spin it nearly as fast. Or the other one is where you've gone to the new big generators where they're actually using a very large armature in order to run it direct drive. You can now put a second prop on that and spin that twice as fast and pull twice the power again. Undersea applications, this is where you're talking about combat diving, UUVs, or even submarines. One of the things, submarines already do counter rotation, but they normally do counter rotation either with double motors or with gearing and whatnot, which is louder and has more of an acoustic signature. With this, you cut way down on any kind of an acoustic signature because there's no complexity to the drive system. And that, I think, puts it back to you, Rick.
Yeah, so this technology is very interesting. We're very excited to get it out there. We've produced over 100 motors so far. We have partnerships with a couple motor manufacturers where we're actually producing these through their production facility. So we're excited to get this out there to everybody else. And again, the whole key here is the counter rotation with no complexities of motors, no dual motors, no gearing, and you get all the benefits of a counter rotating system. So with that, I'll turn it back over to Charles, and we'll go from there. Take any questions if there's any questions.
Well, Rick, John, thank you very much. And true to your word, you kept it to 20 minutes or so. I really appreciate that. It's sometimes rare, but we really, that was a great presentation. We already have one question in the Q&A session. The first one is from Joe Donovan. You referenced payload and watt in your slide. Can you expand to speak to the impact of this platform on the payload for military or intelligence uses?
Well, obviously, when you're talking with military, they're specifically talking with specific payloads. And just basically it comes down to the 40%. You're going to gain 40% payload increase, or you're going to gain 40% more usable range. So it's pretty simple. It's pretty basic. The other thing is particularly if you're using, for instance, hybrid, you get zero torque. So you've got no torque requirements for any of your military aircraft. And the military is using both hybrid and copter. So that actually creates a real simplicity to the system. One of the things that I've been asked many times is, if we don't have torque, how do you get yaw control? Well, you'll notice that all of the copters that are out there, they're already tilting their rotors. That's for the specific reason that using torque only has not proved to be very positive on yaw control. Well, because our motors have a much higher thrust capabilities on these, you just have the same tilt on them, and the autopilot doesn't even realize that it's not using torque, and it's actually using a horizontal vector from the motor itself because of the tilt.
Great.
So I think there was a question about origin of manufacture. So the technology is US based. We currently have a partnership with a company called Vector Techniques. They're in India, They're in the process through a license agreement of starting to produce the motors. The 3 motors you see on this current slide, which are EV 10, 20, and 50, are actually produced by us in-house, but we do them only in low quantities. We do them mostly for prototypes and for development as we send them out to UAV manufacturers as they're building prototypes. So, but as far as production, we do have production in India that's available for, I think our EV20 is in production or close to being in production, and we're working on EV50. So that's probably a few months off. Somebody asked a question about the 100 units. The 100 units were built in California, and those were prototypes that were sent out to various UAV manufacturers for testing. A lot of what we're finding is we have to send the motors to the UAV manufacturers because they just don't believe our numbers. And so we do a lot of one-for-one testing where they'll send us a motor. They'll characterize that motor, send it to us. We'll convert it to the eVector and send it back to them so that they can understand the true benefit of what we're getting from the system. So we've done a lot of prototypes for people in the development process of their UAVs.
And the original area of production, just to get it even narrower, is we're out of Placerville, California. So you don't get much more out in the woods than that.
Very good. We've got, in addition to the question regarding the prototypes and the quantity, what's the typical development timeline for a new design from RFQ receipt to first prototype parts delivery, Rick?
Yeah, so it really depends on what the motor is, and if it's something we've worked with before. For instance, if it's a new motor, it usually takes us probably anywhere from 2 months to do a design, validated design, and then a few months to get up into production. So again, I would say probably anywhere from 3 to 5 months is going to be the time frame it's going to take. And a lot of it just depends on who the manufacturer is. What we like to do is obviously through the customer or directly with us, we'll reach out to the motor manufacturer and try to work with them, because the whole key to this technology is you don't want typically 1 or 2 of them. You want to have a supply chain, a production supply chain. So it's important for us to work with that manufacturer to do that. We can build up to 10, 20s ourselves, but if you're wanting, volume beyond that, we really want to work closely with that manufacturer. And so a lot of it depends on what their time scale is, where they're at in their production cycle, and us working with them to get our technology into their system.
One of the things I think it's important to add to that is that we can probably build a prototype in that 5 to 6 month time frame, but understand that's building a prototype. That hasn't gone through endurance testing, hasn't gone through IP, hasn't gone through those areas. So a lot of that has to do with the complexity of the design and what it's going on to. Just to address the IP aspects of it, we have tested it in heavy water usage. It seems to just throw the water off without a problem. We have not had a chance yet to do it with dust. But again, since we're spinning the armature, there is no surface for the static to pick up materials because it's just throwing it off as fast as it comes through the motor.
So we have a couple more written questions here, both from Elizabeth Elder. Do you have any firm production orders demand from current customers? And what are the geographic regions of your raw material and subcomponent suppliers?
Yeah, so right now we just have prototype orders from customers that we're fulfilling. Again, most of the designs that the people we're working with are in the prototype stage, building test samples for themselves as they develop their products. Nobody's in full production. The components that we use for our eVector line, for our eVector 10, 20, and 50 come from China. Some of the raw components come from China. Our production units will actually come from India. All the parts will be from India. None of them will be from China. That's our current partnership. We are talking to a couple of U.S. manufacturers, motor manufacturers, but we haven't gotten to the point of having them build or work with eVector on them yet.
One of the problems we're running into, Chuck, is and Elizabeth, is that Everybody, because of what's been going on in Ukraine, is buried and is very much tied up in the projects that they're working on right now, which is one of the reasons why everybody's kind of working with the prototype aspects of it and not the production aspect, because they have to go forward with what's approved.
Great. Nick from Andrel asks a question from a production level. Would a company go, how would they subcontract through to manufacturers? Would they go direct to the manufacturers after a prototype stage? What is your preferred mechanism of contracting?
Yeah, we would, our preference would be you go directly to the manufacturer. So what we would do is our business model is really a licensing business model. So our goal is to license the technology out to manufacturers. As I said, we've already got one license through Vector Techniques, but our goal is to license the technology out. Elizabeth asked a question about pricing. Great question. The way that we essentially price this is if you look at the technology and the torque that, or the thrust that is created by a motor, if typically a dual motor or a larger motor, because we're adding a 40% in, will be competitive with the price that you're going to pay for that larger motor for that equivalent thrust. If that makes sense. As you go up in thrust on motors, the pricing tends to go up pretty significantly. And so you get the benefits of all of the technology, and essentially you're paying for the same price you would get for that larger thrust. That's our goal. A lot of it's dependent on the motor manufacturer, because again, we license this to the motor manufacturer, and so it really depends on how they price their motor going forward. We have very little control over that. We just do the licensing.
And Rick, from a licensing perspective, CR Flight can guarantee that Chinese parts and technology are not incorporated in the eVector solutions?
Yeah, again, we work with the motor manufacturers, and so just like any defense contractor, you're going to have to validate that source for that motor manufacturer. We're really responsible for the licensing of it, but certainly we're aware of the issues with T-Motor right now, which is why, again, we moved to India for sourcing all of our parts, because you can't really rely on anything coming out of China. And again, we're looking for we have a couple of contacts with motor manufacturers in Europe we're also working with. But again, we've done some initial prototypes, but we don't currently have licensing agreements with them. But those are a couple companies in Europe that we're working with.
I might add that the only actual stuff we get from China, and we're trying to find other odds for that, is the neodymium or neodymium, whichever way you want to pronounce it, which we just don't have any choices on right now. Nothing else from a technological point of view comes out of China at all.
Yeah, none of the technology. It's all just some of the machine parts and components like that. Like, for instance, if we're looking at our current motors, these are all based on T-Motor U motors. And so we don't manufacture those. We buy the components. In the past, we bought the components from T-Motor to make our current eVector motors.
Great. We have a couple of additional questions. One is, can you name the Indian-based sub-manufacturer?
Yeah, Vector Techniques is the name of the company.
All right. Oh, the other one wasn't actually a question. It was a comment about wanting to work with the team further. We'll open it up for verbal questions at this point. I will say that we've already received a few requests for one-on-one follow-on discussions. So should any of you that haven't already reached out to me or anyone else at the JMH team be interested in a deeper one-on-one interaction with the CR Flight team to discuss your challenges, please route your inquiries through me here at JMH Group. Okay.
Looks like we've completed it.
Yeah, not hearing any, we can give people 14 minutes of their day back to them. So once again, thank you very much to everyone for taking your time and interest in learning more about CR Flight. Once again, we've gotten quite a few requests for one-on-one conversations, off video. So if anyone does have additional requests, please feel free to route them through me here at JMH Group. And otherwise, have a great rest of your week, and thank you so much.